Testing. 1, 2. Testing. 1, 2.
Yeah, I know, that's also what's happening if their function isn't triggering properly. I also don't know why I move around. I don't know when that happens.
Okay, ladies and gentlemen, let's go ahead and get to it. Welcome to another week of EECS 498 Game Engine Architecture. How was discussion? Pretty good. Friday. Those slides should be posted now if you want to review them. I couldn't tell from watching the recording, but I hope there was a good crowd. I do recommend you go to those discussion sections. You can watch it after the fact. But those discussion sections are really going to help you on the homework, especially as things start to get a bit more difficult, okay? And they certainly will, and they will soon, okay? In fact, looking at the schedule, you might say that we've got... we're in the oasis. We're in the eye of the storm for about one more week, okay? And then we're going to get to that auto grader. We're going to start building our engine up. Things are going to get very serious, okay? I hope you look forward to it. Super fun stuff. And let's go ahead and get into it. The first thing I want to show you today is a game engine. Now, you've been used to the drag and drop / beginner engines, the minimalist engines, right, and the integrated engines. But sometimes we come across an engine that is a little bit more specific. It's very opinionated and might be heavily customized for a certain genre. Have any of you ever heard of the engine Mugen? Okay, this is a famous fighting game engine. It's not a super popular engine. You know, you're not going to use this to make your next game. But there's a large community of fighting game enthusiasts out there who have been using Mugen for a long time to create their dream matchups, okay? Creating characters, it's possible in Mugen. Creating stages is possible. Having all sorts of crazy game modes is possible. Just looking at this GIF on the left right here, you can probably get a feel for what the appeal is, okay? You can bring down, you can clone and pull down characters from around the internet, and it's very easy to add them to your game, okay? You can then watch them fight in computer matches. You can play against them yourself. Some of the characters come with their own story modes, with their own cutscenes, with their own voice acting, with lots of fancy art and stuff like that. And I want to show it to you, okay? So I've got Mugen right here on my desktop. Let's take a look here. Okay, here we go. Game engine of the day, Mugen. Okay, engine, and let's go. Okay, arcade. Okay, do we want to be Kung Fu Man or Kung Fu Man? There's like a low-res version and a slightly higher-res version. This is what it comes with by default, by the way. I think I'm going to go with low-res. Let's give it a shot. Okay, we have a cutscene. Okay, blah, blah, blah. Oh, okay, it just ends.
Round 1. Fight.
Okay, no background music. I don't know any moves. I haven't played this in a year. Okay. Well, anyway, right? You get the sense that this is a game that wasn't really meant to be played out of the box, It's an engine that you're meant to customize, to add characters to add stages to. And so let's see if we can do that. All right. Now, I went ahead and I found something. I found something I hope you're going to like. Let's see if we got it right here. Got our Shrek folder. And I can go into characters right here. And I can see we've got a low-res and a high-res version of Kung Fu Man. The character is represented by a folder. And inside that folder are a bunch of files that kind of determine, okay, what aesthetics will the character use? At what frame will we show which aesthetic? Where the hitbox is going to be? What kind of cutscenes should we play before the character's story mode? Stuff like that. I'm going to paste the Shrek folder right in. I'll get rid of the 2. I don't think it's supposed to be there. Oh, maybe I need to put a second level. We're going to try it. We're going to try it out just like this for the moment. But once we add the character, you have to go in and you have to go into the character selection system. I think it's called select.def. And then you have to go in, how to add characters. So you have to go in and actually say, I really want my character here. And which stage is going to be the character's home stage. Okay? So let's write this in just like this. I'm going to save this. We're going to rerun the game here. And we're going to see if Shrek shows up. If he doesn't show up, he doesn't show up. So I think I got one extra level of Shrek folder here, right? So 2 folders, you don't want that. I'm going to take this, I'm going to cut it out, copy it. Did that work? Oh, it did. That's cool. Okay, so let's try this. See what happens. You look at that. Okay, so I don't know what we're going to... This is, you never know quite what you're going to get, okay? Let's give it a shot. So this is Shrek. Okay, I think I used his alternate costume, which is why he's red. I want his normal costume. How do I get that? Is this... Okay. Okay, so I got to learn his moves here. Come here. I think these are all of Shrek's moves. He does not have many moves. So do you know why? Okay. So those aesthetics for Shrek were taken from a Game Boy Advance game. And that was not a fighting game, that was a platforming game, which I think is why Shrek's moveset is so limited. But in any case, I hope you can see the appeal just from that little demo. This is a kind of fighting game system that makes it fairly easy to bring characters in, to make your own. Well, I don't know about easy, but when this debuted in 1999, it was pretty much the only way you're going to make your own fighting game without getting a programming degree, okay? Now, it used to be a mystery, like one of the internet's mysteries, like who made Mugen? And where are they now? They were a company that was kind of obscure called Elecbyte. And it was very frustrating because Elecbyte never provided a commercial license for Mugen. So people who made these big Mugen-based games full of their own characters could never sell those games because Mugen, Elecbyte, the creators, would not license it. Okay, it was a private license, and they just wouldn't let you do that. And they were so quiet, you basically couldn't contact them to try and request a license. And so a couple years ago, a big crack in the case happened. They sued someone, kind of. They sent a cease and desist letter to someone who's trying to sell their Mugen-based game, which you cannot do. And they had a return address of Ann Arbor, Michigan. Okay? When I saw that online like a year ago, I was like, oh, I know that place. And I knew that... So in the state of Michigan, you can look up a company and who owns it. So you have to register your company. It's called the LoRa Entity Database. I know this because I got my own company, and my own company is there. And so I looked up Elecbyte. I found a few names. I found the names of 3 people. What are their names? Website, well, I don't remember their names. But I looked them up in the M community, and they were there. thus providing confirmation that they were University of Michigan students who made this game. So yeah, one of the most famous fighting game indie engines was actually made by people who were sitting in your seats. Not exactly, but you get it. Which was really dang cool. Super cool. It's a small world, and the people who come through here, including all of you, you're really special people, okay? Keep that in mind, especially when the going gets tough. The department wrote a fun article on the topic after I let them know, and they even made this cool little graphic. And yeah, this is
One of my favorite things about fighting games is how different each one feels, even though most of them can be boiled down to something as simple as this.
Right.
Everyone's got a health bar, and your goal is to beat up the other person.
Yeah, so Mugen is well respected, and there's some documentaries on the engine that you can enjoy watching if you want to. Anyway, there's a open source successor called Ikemen Go, and this is compatible with Mugen, all Mugen's assets and files. And this is the kind of thing that will happen to your software if you just leave it there, leave it closed source, and people care enough. Eventually, someone will make a replacement for you. And so this is what is currently happening. And best of luck to them. Because I think I reached out to Electbyte once I figured out who they were, and they have not responded, and that makes me sad. So hopefully one day they do, and enjoy the glory they deserve. Anyway, the development experience. It uses a proprietary CNS format, which there is some documentation to, and it is pretty messy. It does not seem, it's not visual in the slightest. There are not any tools that you can use to kind of do things, at least not that I know of. And so you have to do a lot of this by hand in a text file. This isn't super dissimilar to what we'll be doing this semester with your engines, but I wish they had something a bit more visual to help you add stuff to the game. There are tutorials online. I think there's some tutorial videos as well, editing animations. Compare this to like the tools you get in a normal game engine, where you'll actually have some UI to help you animate characters, organize scenes and areas and all that good stuff. Anyway, seems like a big pain, but you do what you can. Some fun announcements. Has anyone seen the Sonic 3 film? It's a pretty good film. I enjoyed it a lot. The credits scene. In the credits screen, there's a low poly recreation of Sonic, Tails, Knuckles, Shadow, and the Robotniks. My friend made those, which was really cool. He actually told me he had made stuff in the credits before I went to see the film. He made these low poly characters, if you are curious. This is going to be loud, so I'll turn it down. But he made the Robotniks dancing. He made the characters, the low poly characters. And one interesting tidbit is that the Sonic here is, I think, the first polygonal 3D version of Sonic ever made. It was made for Sonic the Fighters, Brent told me. So he just kind of touched up the Sonic model. But Shadow and some of the other characters don't exist in that game, and so he had to make them from scratch and try and match the style. So because I'm making that new 3D interactive art course, this is the kind of stuff that's geeking me out lately, and I hope one day I can have a consistent art style enough to do this kind of cool stuff. Anyway, now my friend gets to tell his friends and family and one day kids and grandkids he worked on a big Hollywood film. That's super cool. The life of a 3D artist and animator is not consistent. It is typically difficult, and finding work is a bit tough sometimes, but the work that you sometimes do find is really extraordinary and really memorable. So impressive stuff, and I'm very happy for him, which is why I wanted to show you. Homework 2 has launched, okay? And you'd know that if you look at the schedule. Right here, okay? Remember, you take your eyes to the left column, go down to the red line. That's going to be today's date. You'll find the lecture plan, but you'll also find, as soon as we get to that day, you will find the next assignment spec. You can click on that to get to the next assignment. This homework number 2, and you're never going to believe this, it's kind of a basic sequel to homework 1, okay? You are given a second week to kind of get a little bit deeper into this game you're making in the 3 different engines you're making it in, okay? The goal here is to kind of get you a feel for what different kinds of engines are out there and how you have to kind of get them to do the things you want. The way that you make collision detection work is very different in a minimalist engine versus a beginner engine versus a integrated engine. In fact, reading some feedback from last year, some students had a big, tough time with Unity figuring out its collision system because, right, in something like Love 2D or Pygame or Monogame, what's a good way to detect collision if you just need a very basic collision? In Monogame or Love 2D or whatever. Yes?
My guess is like checking coordinates.
Yeah, that's checking coordinates is fine. Here's my recommendation. Just do some distance checks, okay? This doesn't need to be complicated or fancy or even fast. If you've got a player character, go through a list, iterate through a list of all the enemies, and then check how far away from that enemy am I. If I'm close to it, let's just say I took damage, okay? It could be as simple as that. In Unity, in Unreal, you're going to deal with kind of more abstract ways of detecting collision. You're going to have to deal with colliders. You're going to have to deal with, if you're doing Unreal, static mesh component. Good luck with that. And it's going to be interesting. I think you'll get a feel for these different types of engines, okay? You're going to have to do some additional stuff. So this week, you are turning it into an actual playable game. Okay, it's going to have a victory state. It's going to have an end state. It's going to have projectiles. It will have collisions and sound effects. If you are used to making games, if you have a lot of experience with engines, it's not going to be a big deal, right? But if you've never touched an engine before, right, this is still a nice early week to kind of get you ramped up, get you feeling good, get you some confidence with game engines for what they are. This is not a super hard assignment, but don't sleep on it either. Okay, you've got 7 days, but who knows what could happen, okay? So, yeah, be careful, start early. You need to do basically everything you see here. So here, you have not 3 enemies, but you have kind of an infinite spawning set of enemies. You also have projectiles. Those projectiles can collide with enemies. The enemies can collide with you, okay? After you defeat, I think, 10 enemies, we go to the victory screen. If you run out of health, you go to the failure screen. You also have sound effects that you need to get in there at the right times as well, okay? So, nothing crazy. This is kind of your last week of syllabus week, okay, before we get into some, somewhat hardcore C++. And so I hope you'll enjoy it, all right? Does anyone have any questions on the homeworks or on anything I've said so far? Okay, awesome. Fantastic. Okay, if you look on the schedule, you'll see that this next lecture coming up in 2 days on Wednesday is our first quiz, okay? From 4:40 to 5 p.m., or if you got an extension because of disability letter, from 4:40 to 5:10 p.m., you have a quiz, okay? It's going to take place on Canvas, and you'll do it here. You can also do it remotely. If you do it here, and I do recommend you come to the lectures, of course, you want to bring your laptop. You want to bring something you can use to do the quiz in the event that all these machines have been taken, okay? It looks kind of close. Like, we might have enough machines in here for everyone right now, but if we get a surge of people attending in person, then you're going to want to bring that laptop, okay? Try and bring it charged if you can, and that'll make your life easy. It's going to be 20 minutes in length, and you're going to have 20 questions. You don't have a whole lot of time, okay? You should not be struggling on these questions too much, assuming that you have read through the syllabus, that you've come to these lectures, and that you've paid some attention. You probably won't have much of an issue, okay, on this first one. In the discussion, they said that they're all easy. They're not all easy, right? They are a reasonable challenge, especially later on, okay? Eventually, we want to verify that you have a good feel for Lua and how Lua works. So we'll have quizzes dedicated to that and other topics like data-oriented design as well. So keep that in mind and don't miss it, okay? Even a mediocre grade on a quiz is way better than a 0. You get to drop your worst quiz score, okay? So don't make it this one. Okay. All right. So what else do we got here? Bring a device that's charged, okay. All right. I think that's about it. So our mission today, our main objective is going to be to do that syllabus day stuff that we skipped on the first day. And then I want to go over and really talk about modern game engines. I want to give you kind of a higher level scoop about all these engines that you're dealing with in your first two homeworks. Before then, we go and create our own. Question?
I had a question about the quizzes. So
Yeah.
are these are individual then?
Mm-hmm.
Okay.
Yeah, do not do quizzes by your with another person. The order of the questions is randomized, so it's going to be kind of harder anyway. When you come in and you start the quiz, we'll all go quiet. I'll put on some really serene music, and for 20 minutes, I'll just walk around. You do the quiz. After 20 minutes, we'll begin our normal lecture, okay?
And then also, will you usually give us like topics like this?
Yeah.
Okay.
Yep. Yeah, so I'll always let you know kind of what the upcoming quiz is and roughly what topics are being covered, so you kind of know what to study. On this one, it's the syllabus, course policies, which we'll go over today, and then a handful of just general and basic ideas about game engines. Again, this is not going to be a super hard quiz. Don't panic too much. Okay, so let's go ahead and let's get started. I'm going to go ahead and quit Discord so we don't get beeped during lecture. Let's talk about some course logistics. So I've shown this clip 2 times already today because we're doing syllabus day in every one of my courses. How many of you have watched SpongeBob? Okay, you've probably seen this clip. Okay, I really like it. Let's watch it again. So when logistics go bad, when scheduling goes bad, when policies aren't known, it never looks like this, but it can often feel like this. So today we're going to go over some of those policies and the course structure just to make sure you've gotten it all from the syllabus. So lectures, 4:30 to 6 p.m., Mondays and Wednesdays. You're doing a good job with that so far. We'll have standard lectures, which tend to be a bit softer in their topic and tone. History, theory, discussions, and stories. We're going to get to some of that today. That's what today's main focus is. But we will have some lectures during the semester in which we go in and we kind of demonstrate concepts to you. We do some programming together, and this is meant to mainly be as help for the homework. You'll also get some of this at your discussions, okay? So very pragmatic stuff. Chances are we will have another guest lecture or two. Last year, it was Nathan Hainish of Stardock, their lead engineer at Michigan's largest game studio in the state. And our discussions, right, which happen every Friday, will be very focused on homework, very focused on nitty-gritty topics, giving you tips and advice to help you through those, okay? I would generally say that in my courses, the assignments are the star of the show, and the lectures and discussions are meant to support those and help you get through them, okay? And so that's a good way to think about this. You do these assignments, you're going to learn a lot. A quick note, Windows, again, is the staff development environment. And so it'll get the most support. But we do have knowledge on the staff, right? I've got knowledge of how to, for instance, fix things in Xcode, get Make to work. So if you don't use Windows as a primary dev platform, you're still going to be okay. You can still ask questions. You'll be fine, okay? Some computational resources. So in this course, you will shortly need the ability and access to Windows, OS X, and Linux. Okay? You'll need this because you need to test your game engine across all 3 of those platforms. By the end of the course, you'll have a game engine that is multi-platform, much like Unity or Godot or Unreal. You can bring it down to any laptop and it will work, okay? And it's a really satisfying thing. I think you'll enjoy it. However, getting access to all 3 of these operating systems is not always trivial, okay? You might have some of these, and if you do, that's going to make things a lot more convenient for you. However, there are ways to get access to all of these. So with Windows, right, you can visit the Kane Labs. You can just work in here if you want to. I've built my engine in here. It works pretty well. With OS X, we've got some really good developer-friendly machines just across the hallway in this nice kind of OS X laboratory. They've got a recording booth in there. They've got a desk that's usually got people up there to help you if you really need to install something or something like that. So it's not too bad. As far as Linux goes, typically these Kane labs, I don't think this one does, but most Kane laboratories allow you to boot into Windows or into Linux. And so you should be able to use those for testing as well. There are money-intensive ways to fix these problems. You can purchase a PC, you can purchase a Mac or a Linux box. You can borrow these things temporarily from your friends if you have friends who have these boxes. In general, you will develop your engine for the week on one platform, Windows, let's say. And then, once you're passing most or all of the Windows test cases, you will do a port over to OS X or over to Linux, okay? And the other two platforms, you'll run it, you'll get it building, great, okay? You'll push it, and chances are it will actually, if it runs and builds, if it builds and runs, it will probably get you all the points and test cases on the other two platforms if you've got it on the first one. Sometimes there are little things that you have to fix between platforms, but not a ton of those. So it shouldn't be too bad, okay? The high-level schedule, a reminder, in these first 2 weeks, we're dealing with modern engines. We're about to begin, next week on Monday, we'll begin with our main production period of our game engine. We'll then take 1 week to focus on the exam, and then we will do 2 weeks at the very end to add something custom to your engine, okay? A research project, kind of. This can be really ambitious, like 3D, or it can be something a bit less so, like DDR DancePad, okay? And whatever fits your schedule is what you can go for. Keep an eye on the course schedule. We've talked about it a few times, but this is where you can get access to everything you really need. Lecture plans, the slides, discussion plans, assignment links, deadlines are right there. Green means it's about to start. If you see a yellow block, you should be working on something, and if you see a red, it's due. There are some missing elements here. So if you go to the assignments through Canvas, you'll actually see additional information about each assignment. So for instance, you can see how we're going to grade these things. You can go to homework 1, for instance, and you can see in this rubric that we're going to grade your 3 engines to these standards, okay? So check the rubrics if you can. You'll get some additional information that might be of use to you. Okay, some quick grading and policy notes. How many points are in this course? I always thought it was funny. If I say there's an extra credit worth 5 points, is that a lot or not worth caring about? Like, what if the course has 50,000 points in it? Not so interesting. But if the course has 500 points in it, then that's a crazy valuable extra credit assignment. You should definitely do it, right? Well, in this course, we have 1,000 points total, okay? I don't think I messed this up. It's going to be around 1,000, even if I did. The explorations that you're doing are 100 points, okay? 50 a pop these first 2 weeks. That's quite a lot. It's meant to boost all of our grades, get you some easy points early. The engine production is going to be about 35% of your overall grade in this course, okay? A big chunk. You don't want to mess that up. The exam is going to be about 25% of the points in the course. I might play around with these a tiny bit. I probably won't this semester. Maybe next semester I will. But this is to say that the exam is valuable, but it's not one of those crazy exams where it's like 60% of your overall grade. So if you have a bad day on the exam, which you probably will not, it's not that hard of an exam, then you can recover, okay? The final 2 weeks are easy. They're easily graded. You're going to get this 150 points without a whole lot of sweat. And yeah, that's engine research, 15%. The quizzes will be about 100 points, 10% of the overall grade. Do the best you can on that. And you've got one postmortem assignment at the very end of the course where you write up and kind of reflect on your experience developing the engine, and that's going to get you 50 points pretty easily, okay? So there are a couple extra credit opportunities, not a ton, not like 494. But at the bottom of each assignment, you've got that provide feedback, right, button. You click that button, and you're going to go ahead and get some points, okay? At the end of the semester, we'll give you some points for doing this. This is what I'm talking about right here, provide feedback. A lot of you have already done it. I really appreciate it. It really matters for such a young course to get as much data and feedback on what's working and what you want changed as possible, okay? The target median grade is a B, and I think we just about hit that last semester. Maybe we had like a B plus average grade or something. And I will say, I think that this semester, even with the additional assignment, homework 9, will be easier than last semester, simply because the assignment specs have received an extra pass of polish, and some of the tech has been improved. The autograder is better than it was last semester. So long as I can get it running again. I have to get it running this week. Wish me luck on that. But yeah, I think it's going to be an easier semester, so I wouldn't be surprised if we hit that B plus or A minus average. We'll have to see how it goes. In any case, we don't tend to curve in this course. I guess if the exam just wallops everyone and the average is way too low, we might curve everyone. Probably not going to curve, though. So for the collaboration policy, check the assignment specs. They sometimes have restrictions on them. But in general, we're pretty permissive in this course, okay? We want you to talk with your peers. The people in the lab here, we want you to talk even about the assignments. We don't want you to share code explicitly, right? You're good to talk about techniques and data structures and ideas you might have that might be good. Do not directly copy code. So long as you don't look at each other's code, you are almost certainly in a good spot, okay? Even if you do look at each other's code, as long as you're not copying it over, you're probably just fine, okay? So, yeah, work together to a small extent and help each other out, okay? There's not going to be a curve. Helping someone out does not hurt you at all, okay? Participation here. Do you need to attend every lecture? You do not, okay? You probably heard my story about the slippery slope. So the technique, how it goes with most undergrads, is that on the first day of the semester, you're super bubbly, you're confident. Yeah, New Year's resolutions, right? You're going to go to the lecture and you're going to sit in the front. You're going to be awake the whole time. You're going to answer all the questions. It's going to be great. The second lecture, you're going to go there and you're going to sit in the back, right? You're a bit tired, no worries. You're going to sit in the back and fall asleep. The third lecture, you don't even come to lecture. You watch it in real time from home. The fourth lecture, you watch it from home, but with a day's delay. And by the fifth lecture, you're not watching any lectures anymore. Okay, suddenly the course is getting very hard. And you don't quite understand why. And so it's a very slippery slope. Just be careful about that, okay? You do not need to come to these lectures, but be careful that you don't fall too far off.
Where's the button that I click that says I'm in this picture and I don't like it?
You're in this picture and you don't like it?
Yeah.
What do you mean?
I feel very called out. But
oh, called out? Oh. There's so many students who do this every semester. I don't even remember who. Right, hey, some people can deal with it, okay? You can play on hard mode. You can do this course on hard mode if you want. That's up to you. But I recommend that you come in person if you can. You're paying a lot of money for us to help you and accelerate your journey through this game engine production. So make use of that, okay? But I understand. You've got other courses. It's only the first week, second week, and I'm already exhausted. So I can't imagine you're feeling too much better. And so I get it, all right? Must you attend every lecture on time? The answer is no. Why am I even asking this up here? In the old days of 494, pre-pandemic, we took attendance and you had to be there on time, okay? Big penalties if you weren't. So yeah, that is not the case anymore. Lectures are recorded, okay? Discussion sessions are recorded, and these lectures are recorded as well. You can watch these in real time on Twitch, but please know I don't look at the chat, obviously, and so I can't answer your questions if you ask them while I'm teaching, okay? When are things due? Typically the start of class. So 4:30 p.m. EST on Mondays and Wednesdays sometimes. That's going to be the due date, and that is actually late, so you need to have it in before then, okay? And Canvas is the official timekeeper for those checks. Late penalties are kind of interesting. So when it comes to the autograder, the late penalty is different in this course than in 494 or 440. You can submit any autograded assignment at any time, and if you are late, you get 20% off. But if you're late 1 second versus 1 month, the autograder doesn't care, okay? And so keep that in mind. For these first two homeworks, there actually is a due date, and you'll get 20% off if you're late, and then after 24 hours, you're 100% off. But for most of the auto-graded assignments, you can be a week late or a month late or a second late, and the auto-grader don't care, okay? Be very, very careful about this policy. There's a temptation to let the assignments build up and get away from you and escape from you. But at the very end of the semester, after the exam is the auto-grader off date, which is when the auto-graders all shut off, and that's just the score you've got, okay? That's going to be, let's see here, the exam is 1670 BBB, April 4th, 5 to 9 p.m. The following Monday at 4:30 p.m., the auto-graders turn off, and you're not going to get any more points from the auto-graders, okay? So don't let these things get away from you. You don't have a whole lot of slack on the back end to catch back up. And those 20% penalties are not fun. Okay, another thing to note, if you get behind, right? If you get way behind, the course becomes more difficult, unfortunately. If you are working on homework 3, but the course, the lecture contents, the discussions are talking about homework 5, right? When you get to homework 5, we'll have moved on, and you might not have the information you readily want right there ready to go, okay? You'll have to dig through some lecture recordings, discussion slides. It's not going to be as pleasant. So do what you can to keep up if you can. You're a few days behind, no big deal, but don't fall too far behind, and let me know if you're starting to. Okay, blah, 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 blah. That's the late policy for the first couple assignments. What if disaster, right? You get extensions in this course, but in general, only for things outside of your control and only things that are affecting the students widely, okay? If Canvas goes down or if the auto-graders go down, last time we taught this, I think the auto-grader went down on like the final day of like homework 3 or homework 4. And it was down for a while because I couldn't get to the office to fix it. And so we gave you a couple days extension. That's just how it goes sometimes. Probably not going to be as common now that the auto-graders are a bit more stable, but we'll see. Quizzes, okay? Quizzes and exams are really important these days, right? With the rise of AI, with the rise of software that can kind of do some of our jobs for us, we really want to make sure that you personally have an understanding of the topic and the materials. Exams are a traditional and kind of painful, but pretty good way of doing that. And so we have one. Upper-level CS courses must have an exam, and so we have one. Bi-weekly quizzes, bring a device. Okay, you take this on Canvas. 20 questions, 20 minutes. We tell you the lectures a bit ahead of time. Not usually all that hard, not super easy or anything, but not excruciating. And your lowest score will be dropped. In reality, what that means is that we take your lowest score and we just make it max points at the end of the semester. Okay, it's one way to do that. For the exam, it's going to occur in person. It will occur at the end of production. Okay, we'll have a week at the end of production to review for the exam and then the exam. And the time of day is going to be 5 to 9 p.m. We're going to have one alternate exam, and I think you've got like a couple days to ping me about that if you need the alternate, because we got to organize everyone and get everyone onto that alternate timing. But yeah, I'm also going to need a very good excuse as well. Time of day, likely evening, and the exam, because the project and the homeworks are pretty hard, the exam is not going to be designed to be particularly hard. If you are doing these assignments and homeworks and projects and doing a good job, I think that you would do a solid job on the exam without a ton of study, okay? Just some would help you out. Accommodations, yes, I've already got your letters. If you didn't get a letter through the SSD office, let me know. But 1.5 time on quizzes, okay? So you get a little bit of extra time on quizzes, and then on the exam, 2.5 hour exam, but I'm just giving everyone 4 hours. So there's your 1.5 on that, okay? Resources. Office hours. We've got quite a few office hours. Let me check real quick. 494 has office hours, I think, every day except Sunday. Let's see if this is better. Woo-wee! All right, let's go. This is every day except Tuesday. All right. Now, no one is doing their homework on Tuesday. Okay, only the top students are doing homework on Tuesday. This is all to say you should do your homework on Tuesday. But we got lots of office hours throughout the week. Okay, a reminder: all of these office hours should also be remote possible. So if you ping us on Discord, and you do probably have to ping us a few times to get our attention, because we could have in-person people, a big queue in person. You can ping us. You can get office hours remotely. It might not be as successful because we can't debug things right there. So debugging is harder, but we can probably still help. Okay? Yeah, so office hours every single day except Tuesday. Our staff is really fantastic this week. I'm grateful to them for their time. Okay, let's keep going. The chain of help is really important, okay? So this course asks you to do a lot of things in a fairly small amount of time. You also have other courses and responsibilities as well. So have you ever had this happen to you? You are working on an assignment or a project, and you run into a bug or an issue, okay? And this bug is just really hard to deal with. And soon, you realize that you've spent 4 or 5 hours just banging your head against that bug, okay? Smashing your head against the wall. How many of you have done that? Okay, I'm going to beat this bug, and then after like 6 or 7 hours, you finally get past the bug, and you're like, whew. Okay, if you do that in industry or in grad school or in this course, you will get wrecked, okay? That is an extremely irresponsible use of time. You've burned most of that time, okay? You do not want to do that. This course is designed to punish you for it, as it should. Here's what you should do. 15 minutes, okay? 15 minutes, maybe 30 if you're feeling kind of lazy. You work on the thing, you poke and prod the problem, you try and fix the bug yourself. You do experiments, you Google, okay? But after 15 minutes is up, after the timer goes to 0, you go to Piazza, you post the question. You go to GPT, you see if you can ask your AI assistants to help. Maybe you can copy and paste an error message in, and you can get some insights into what might be happening that way. You then, after creating that Piazza post, you go work on something else, or you go to lunch, or you go to work out, or you go sleep, okay? You use that time wisely for some other purpose. Have any of you taken 482? What you've effectively done here is you've launched a background thread, okay? Because while you are sleeping, your instructors might see your Piazza post, your peers might see it and go, oh yeah, I just ran into that, here's how you can fix it. Boom. Your problem has just been fixed and you spent 15 minutes instead of 5 hours, okay? That is how you move efficiently, but it does require you to drop your pride a bit, all right? Don't be prideful. Ask for help when you need it. If Piazza cannot help you, you take it to office hours. We got a lot of office hours every single day, and so take it there, and you can almost, there's a very high chance you'll be able to get it solved, okay? In many cases, I've seen a ton of students who come into my office hours for 494 or 440 or even 498, and they say, Austin, I've burnt like 6 hours on this darn bug. Can you help me? And I look at the bug, and I tell them they missed a little checkbox in the Xcode UI. Okay, you have to click that checkbox. See, it's right there in the guide. I guess you missed it. The knowledge we need to solve our problems is often not very big, okay? And the distance between where we are and where we want to go is often really, really small if you have just a tiny bit of knowledge that you might be missing, that your instructor might have. And so, please focus on time efficiency in this course, and you will get lots of sleep and you'll be very happy, okay? If you find yourself going super late into the night, then things are starting to go wrong, and we want to ask ourselves why as soon as we can. For private correspondence, I recommend Piazza, okay? But you can also email me, aarger@umich.edu, if you want to. There are a lot of great orgs on campus that can help surround you with really intelligent people who love the topics you're invested in. So ARI, right, Wolverine Soft, IGDA Ann Arbor, these groups have weekly, well, in IGDA 2's case, monthly, meetups. where you can go and talk to people. You can show off your engine if you want. If you've got issues with C++ or something else, you can ask them questions, right? Have you ever seen this message? You have any idea of what might be going wrong? And that's going to help you out a great deal, okay? As far as health goes, this can be a very stressful course, okay? Very, very stressful course until the exam is finished, and then it becomes really chill and really nice. CAPS is the kind of centralized mental health service here at the University of Michigan. They got a bit of a wait list, but I've heard that they are very good when you can get time with them. Your instructors are a really good resource for health, mental health, physical health. If you feel like things are starting to break down, if you feel like things are getting too far out of hand, you're falling too far behind, oh gosh, I got to drop the course, I got to go do something else, I'm going to lose my mind. If you ever feel like you're having a bit of a breakdown or meltdown, reach out, okay? Reach out as soon as you can. We have seen a lot. We've been teaching for a long time, and not this course. This course is fairly new, but last time I taught it, I saw a lot of students run into a lot of problems. I might be able to help you out, okay? I might be able to give you some perspective. There were a lot of people last year who thought they were going to fail, but they were neglecting the extra credit that was on the way. They didn't realize they were going to do really great in the exam, and that was going to pull them way back up, right? And so talk to us if you're ever feeling really down, okay? You can come to office hours. We can keep it private if you want. And hopefully we can give you some time-saving strategies. We can put you back in a good place mentally. We can help get you back on the road and get you through this, okay? And when you get through this, I think you'll be really proud of what you've accomplished, okay? Anyway, number one rule, same as in my other courses, please let us know. Please communicate. Please reach out. Please let us know when things are going wrong, if you don't feel comfortable, if you're confused, if you're sad, if you're struggling, if you're stressed out, because we cannot help you with problems we do not know about, okay? So please don't be afraid to do that. Don't be prideful. The learning process is not easy, okay? Any easy learning process has you learning nothing, okay? And so please reach out and utilize your resources when you can, okay? Any questions? Any questions, any comments on any of this stuff? Okay, good. All right. So today what I want to talk about is I want to talk about game engines at a higher level. I want to talk about modern game engines and the different types we have. And I'm not just talking drag and drop, minimalist, and integrated, okay? I want to give you the spirit and the background of game engines to the extent that I can. A little bit of this was talked about in discussion and in your homeworks, but I want to go a little bit deeper, okay? So I've got a question for you. What is behind this curtain? This is a pretty famous curtain, okay? Ethan? Super Mario Brothers 3, okay? A very well-regarded game for Nintendo's NES. I think it came out in like 89, maybe? And it opens like this. This is how the game starts, right? The curtain rises, and you see with this black background backstage Mario and Luigi jumping around when suddenly all the props come in, okay? And it's exciting, right? It gives you this sense that you might be watching a theater show, which is pretty fun. In this footage, you can see the end of the first stage. As you run off a stage, right, as you complete the stage, it's meant to look like actors running off the stage, right, to go do the next scene, and then the next scene gets set up. And so you might, if you think about it, get this vibe that video games have been associated with theater for quite a long time, okay? And in particular, one of the oldest and most famous companies, Nintendo, has been very into theater for a very long time, okay? These motifs just keep showing up. From Mario Advance or Mario 2 to Paper Mario is all about theater to other recent games, right? And this comes back to something that one of our most famous early developers, Shigeru Miyamoto, and his team did while they were developing these games. So Nintendo's extremely private, and the early days of Nintendo are not super well known or explored or investigated. But we do have some stuff. We have some early footage and early interviews from that time period. And in this documentary right here, we can actually kind of get some footage of what their offices were kind of like behind the scenes. They look very tired, and I don't blame them. But one thing that the team would do is that they would work super hard. In fact, they would work so hard, this is going to sound morbid. You know what oh goodness. So I can't remember where I read this, but you know what crunch time is called at Nintendo? Okay, video game industry kind of known for crunch. There's not nearly as much of it as there was in the 90s. Things have calmed down a lot. But in the 90s, crunch was very prevalent. And at Nintendo, it wasn't called crunch time. You would work all day to about, 6 or 7 p.m. And then Mr. Miyamoto come over to your desk and say, hey, it's Mario time. And what that meant is that you were going all night. Okay? Mamma mia. And, yeah, those games were magical. And the blood, sweat, and tears that went into those games. Ooh, I don't really want to think about it. But what they would do is that even when they were working super hard, they would take the team out and they would go to the local theaters. They would do this quite often. And so their games started taking on that theatrical, dramatic, overacted vibe. Okay? And they weren't the only team doing this. When you look at this theater performance right here, you see a few things that maybe will sound a bit familiar to you. Okay? Here, we are looking at a kind of dynamic, interactive world that was put on very quickly. There is an element of fakeness to it, as if it's not quite real, but it is providing that illusion, isn't it? Okay? Over here, you see a bunch of actors. All right? You see a bunch of actors, some doing really important things, some doing less important things on the side. These actors, right, they're engaging with props. Okay? And this entire container for the actors and the props and everything is a scene, okay? Scenes often are used to represent different levels. For instance, in a Mario game, or in a more modern game, a scene could be an area, and it's adjacent to another scene that gets loaded in as you walk toward it, okay? If you want any of these actors to do something, what do you have to provide them with? A script, right? Of course, because how does the actor know what it wants to do unless it has a script? In this case, you often provide different actors with different scripts, multiple scripts, okay? You might have one actor who's primarily dancing, but you might give another actor that same dance script, but you might also give them some additional scripts, a singing script, or a script for more lines of dialogue, or whatever the character's going to do, okay? And thus, the terminology that we have in game engines and game development in general, it's very wishy-washy, it changes, but in general, most engines have some connection to the world of theater, okay? So you often, in the world of Unreal, for instance, a thing within an engine will usually be regarded as an actor. Okay, that block is an actor. Mario is an actor. The Goomba is an actor. But you also sometimes get actors that are a little bit less physical. The timer in the UI is an actor. You might have an invisible actor whose only job is to manage the pause menu. It just listens for you to press the start button, and then it draws a pause menu if it needs to. Okay? You've got objects. In some engines, those are called props. They're not interactive. They're just sitting there, decoration. And then, in many cases, you will call a kind of collection of actors a scene. Okay? This is definitely the case in Unity. Okay? In Unreal, it's called a map. You know what's really frustrating about all these modern game engines? They all use theater terminology for a tiny part of their engine. So Unreal uses the concept of actors, which makes sense. But when it comes to say, oh, you're going to use scene, right? That makes sense, right? No, they use map. Okay. Unity is the opposite. Okay. Unity, oh, you've got these scenes, right? Oh, and the scenes are a collection of actors, right? That makes total sense, right? No. They're called game objects. Well, Unity also used scripts, right? So they almost got it. So the terminology we will use in this course will be a collection of bits of terminology used in all the modern engines, in particular the ones that relate closely to the realm of theater, which might be, the industry, the art form that video games draws quite a lot from, right? Theater and film and all of that. Okay? You've got scripts that get put on to these various actors, okay, to make the game run. Some actors have multiple scripts, okay? Later, we're going to start calling these components. We'll talk about the design pattern of composition, something you're very familiar with if you've taken 494 or 440, but a very, very powerful way to reuse logic across many different actors at once, okay? And when you look at Nintendo's games and characters, they really do buy wholesale into that theater terminology, that actor motif, okay? When you look at Mario, you see him often like this, but when necessary, you see him like this. In fact, if you need him to be a doctor, he'll do that for you. If you ask Mario to be a tennis player or a baseball player, he'll do that for you too, or a kart racer, okay? Nintendo looks at their characters as actors, okay? Not as Mario in a universe that is his. Mario can be used for anything, okay? You can bring him into any game, any genre, and he will fulfill the role given to him. He is an actor, and that is maybe makes sense if you play on a lot of Nintendo games, okay? So, this is what a typical game engine editor looks like. We already talked about this the other day. You can see the Godot, right? How many of you are doing Godot in the homework 1 and 2? Okay, awesome. Very good. If you're confused, if you want it to feel more like Unity, come talk to me during office hours, because in a few sentences, I can turn Godot into Unity for you, okay? And unless you know these things, you'll be like, Godot is weird, these nodes, I can't put multiple components on a node, it's like awful, it's not Unity at all. No, we can make it Unity, but you have to know a couple things, okay? Anyway, Godot, all right? This is Unreal, and we've got Unity, okay? And when you look at these editors, right, you can see the actors inside of them, right? You've got a block, okay, that's very visible. You've got a camera, that's an actor. You can't see it, but it allows you to see into the world. And you've got this light right here, okay? These are all actors. These actors are in a scene, okay? And if you click on an actor, you can see all the scripts that they are performing. In this case, this block, this cube, is the actor we've clicked, and it has a transform script. It has a cube mesh filter script. It has a mesh render script and a block collider script, okay? Block collider allows it to touch things, bump into things, makes the physics system work. The mesh render is a script that lets us see it, makes it visible. The cube mesh filter is a really weird script. All it does is it holds the geometry so that the mesh render knows what to draw, okay? And then the transform script is another container that just allows you to have a position, a rotation, and a scale in the scene. That's it, okay? So the standard terminology, the big takeaway here is that when you think about game engines and you're trying to think about how can we formalize this, go back to theater, okay? It has a lot of connections to it throughout its history, and it still works shockingly well as an analogy for what's happening in your game engine, okay? This is the integrated experience, by the way. You have so many things to look at, so many little bits of UI. How many of you liked, this week, how many of you liked the integrated engine the most? All right. Rock and roll. Yeah. Okay. How many of you liked the minimalist engine the most? Okay. And the drag and drop / beginner engine? No? Oh, MIT Scratch. Rest in peace. Yeah, that's about right. Okay, a lot of people love the power of the minimalist engine, the control, and they don't like the cruft, right? Unity has so many features, and if you don't need the ball, well, it's not so nice. It slows things down, it gums up the UI. But if you love those features, if you want to explore them, you want to use them, then the integrated engines are really the way to go. So we got these integrated engines, Unity, Unreal, Godot, Scratch, right? I got a question for you. do we actually need all of these concepts, right? Engines have the concept of a scene, an actor, a script, right? That's what modern engines typically have. But do we really need them? What do you think? Yeah.
I think you don't. This is just what most engines have sort of standardized on. But
Yeah.
you can definitely make an engine that doesn't have, let's say, scripts, and just each actor has its own set of code associated with it. You don't script anything. Game could all be one level, so you don't have scenes.
You know what? I went to GDC. There was this rhythm violence game. What was it called? It was called Thumper. I didn't play Thumper, a rhythm game. It's a very fast-moving game. I went to a talk at GDC where the developers discussed how they made this entire successful indie game, big game, in 5 C++ files using 5 functions and no classes. Okay? Hey, if it runs, okay? You do you if it works for you, right? You can do whatever you want. These concepts have been formalized across many integrated engines because they're very useful. They help you move fast. They help you think about the engine. They help other people learn about how your engine works. But the world of minimalist engines is also pretty interesting. If you look at engines like Monogame, Love2D, Pygame, right? If you compare them to the theater situation we have with integrated engines, right? You don't really have the same things. It's much more basic. What do you get in a minimalist engine? Okay? Oh, I really like this clip. Do you remember the Iron Man film? Okay, there's this scene that I just love to death, and I think of it in many cases. Let's take a look.
It's impossible.
Tony Stark was able to build this in a cave with a bunch of scraps.
But, sir, I'm not Tony Stark, right? And so there's kind of an immense appeal to many people building exceptional things with a limited amount of resources, okay? Starting from scratch is a very appealing idea. In fact, one of the courses I've got on my back burner that I'm designing is a course about historical computing, where we go back to the 80s and we build NES games from assembly language. And usually when people hear about this, they think it's really, really cool. Sounds like a fun idea, right? When we go to a minimalist engine, that's what we're dealing with, a box of scratch, okay? Usually we are given some very tiny things. We're given a game loop, an update loop, okay? So basically, what does that mean? It means we're given a function that is guaranteed to run every frame. That's it. That's it. That's all we get. We can put whatever we want in that update function. Everything has to be driven from it. So in Love2D, it looks like this, love.update. It'll get called for you, and that's it, okay? You have to plug into that and do your thing inside of it. You're usually given some functions that allow you to do super basic operations, like draw this image to this location on the screen, okay? In this case, we've got mono game, spritebatch.draw, okay? That's what you're given. And finally, you're usually given some functions that allow you to check the current state of your input. So how do I know if someone, this frame, touched the up arrow key? I might want to do a jump, okay? And you can see in Love2D, right, it's love.keyPressed, provide the key you care about, and there you go, all right? And that's kind of it, okay? There's no concept of actors. There's no scenes. If you want to build those concepts up, you have to get in there and actually code it up yourself. You might use classes to do so, and it might take you a while. You're going to run into some bugs recreating that wheel, okay? But a lot of people really, really love that, okay? They love the power. They love the responsibility, okay? Anyway, when you look at these integrated editors, they're so fancy. You look into Unreal Engine, you walk through the Viz Studio, you see it open on people's screens, you go, wow, if only I could learn Unreal Engine, okay? All of this extra stuff you're given to in these modern integrated engines, they are not free, okay? There is a complexity cost, all right? Learning takes longer. Okay, navigating the UI takes some time. It's very intimidating at first. It's difficult to remember. There's complexity, there's constraints, there are performance downsides, okay? One of the problems that Unity has always had is that it can make any genre. Does that sound like a problem to you? Unfortunately, it kind of is. Because Unity needs to support any game of any genre, it cannot be optimized easily for any genre, okay? And that'll become a problem later. I'll say a lot of people love the minimalist engines because of their simplicity and the control they give. You only build out the complexity that you need for your current game. Also, a lot of people just love that underdog vibe, okay? No, I didn't use Unreal Engine. I used Pygame. Yeah, right? I mean, why did so many of you choose Pico 8? A lot of you did. Why did you choose Pico 8?
This is so restrictive and funny.
Yeah, it's restrictive. No way you're going to make a good game in Pico 8. And then you do it, and it's awesome. It feels great. It's a challenge. It helps you focus, right? It's good stuff. Anyway, an interesting question these days is, should I grab an off-the-shelf engine, or should I take EECS498 and build my own engine from scratch? Okay? Proprietary engine versus off-the-shelf. Okay? 498 versus Unity. What should you do? Well, it's kind of an interesting question. But for most people, the answer is going to be pretty obvious, okay? With these off-the-shelf engines over here, we got Unreal, Godot, Unity, Godot, Monogame, okay? Versus proprietary engines, things like Creation Kit. Do any of you know what this logo is right here? You've probably seen it.
Is that Frostbite?
That's Frostbite, EA, okay? This is made by DICE. Originally, it was made for the Battlefield series, and it was made to be a first-person shooter game engine with a heavy focus on destruction, okay? Dynamic destruction of structures and houses and buildings for cover, right? You want to make a Battlefield war-style game? That's really important. EA now tries to use this engine on everything, okay? Including The Sims, I think, and that has caused no lack of heartburn and problems. I think BioWare, the RPG company, had some horror stories to tell about using this FPS engine for their RPG games. Okay? Anyone know what this engine is?
Wait.
Quake? Do you know that for sure? Because I asked because I don't know. I knew last year. Dang, Nikki is not still over there. Nikki took my course. Maybe she could tell me. I think this is the Sucker Punch engine. I think. Okay? I don't think it's Quake. So these engines over here are made by one studio, and they're used by that same studio. They do not tend to allow... Wait a second. Hold on a second. No, I think this is Decima. Yeah! Death Stranding engine. This is the Amazon simulator engine. So also used on Horizon and Guerrilla and some other stuff. This is made by Guerrilla Games. Yeah, okay. Killzone? Yeah, gotcha. Cool, I'm glad I remember that. I thought this was the Sucker Punch internal engine. Okay, some of them have logos and names, some of them do not. But these are generally made by a particular team, and they're used by that same team for that team's games. They're not shared, okay? So why would you go off the shelf versus in-house or vice versa? Well, some of the examples here, right? You got Monogame and stuff. You got Creation Kit, Bethesda's engine, EA's engine, and Sony's engine, okay? The studios that use these, right? You've got over here Square Enix. You've got MiHoYo, okay? You've got Stardock. They use a lot of these off-the-shelf engines. These tend to be more third-party, okay? A lot of indie studios tend to use off-the-shelf engines as well. Over here, what you'll notice is that, yeah, you've got some third-party studios that use these in-house engines, that make their own engines, but the in-house engines tend to be a bit more popular with the first-party studios. What do I mean by that? I mean Nintendo, who makes the Switch console. Sony, okay, right, with Naughty Dog and Sucker Punch, who makes the PlayStation, all right? In terms of expense, right, when you look at an off-the-shelf engine these days, it costs you nothing to start with Unity and Unreal. And until your game is a big hit, you don't have to pay much of anything. All right? Not super pricey. Meanwhile, if you choose to make your own engine in-house, you need some very specialized engineers, the kind of engineers we get out of this class, maybe. And you need to give them a lot of time and a lot of resources. Okay? If you need a new feature, right? If your engine doesn't have a feature, you can't just wait for Unity to make it. You have to make it yourself. Okay? And so that can be kind of tough. The upside here, though, is that if you do have a massive hit, all right, with Unity and Unreal, you have to give many, many millions of dollars to them in response to you getting a hit. Over here, you pay nothing. You don't pay any licensing fees. It's your engine, after all. Okay? Recruiting, okay, is another sore spot for in-house engines. There are a ton of places that know how to use Unity, a ton of programs, a bunch of universities teaching Unity and Unreal, okay? There are lots of other companies using these exact same engines, and so if you need to hire, you can hire from universities, but you can also hire from other companies using the same engine, right? Okay, how many people out there, how many college programs do you know of teaching the Decima engine? Okay, if you wanted to learn the Decima engine, where are you going to go? What are you going to do? You know what you're going to do? You're going to go to GDC, you're going to go to YouTube and hope that some of their devs did some talks on Decima. Okay? That's probably the most documentation you're going to get. Those engines are in-house, they're under lock and key, they are the secret sauce for those teams, and so they don't want you to know. Okay? But as a result, no one knows. So if you're a company that has a proprietary engine, the best you're probably going to do is say, our engine is C++, it uses Lua as a scripting language, okay? Box2D is physics. Let's try and find someone who's good at C++, Lua, and has maybe touched Box2D, okay? And then we'll have to spend a bunch of time and money training them up before they're of any use at all. That stinks. That's not good at all, right? Very nasty. In terms of community, okay, if you need to go find a tutorial or learn more about one of these off-the-shelf engines, you just go to YouTube, okay? You can go to YouTube, you can go to your local meetup, you can go to the documentation online. It's fantastic, okay? One of the best things about these open off-the-shelf engines. But in-house, you might have an internal wiki. I hope it's up to date, okay? How many of you have heard of a game called Mass Effect Andromeda? Oh, no. Okay. The game didn't do so well. Okay, and for many reasons, you can go watch videos online, documentaries about the troubled development process that Mass Effect Andromeda had. But one of the problems that BioWare ran into when they're trying to make that game was that they were using Frostbite to make Mass Effect Andromeda. Okay, and Frostbite was not made by BioWare; it was made by another EA team, DICE, in Sweden. Okay, BioWare was in Austin, Texas, and they could not get enough time from the Swedish, engine developers to get the features they need added. They couldn't get the documentation, they couldn't get enough attention, and they were starved for it. And as a result, they just couldn't get the engine to do the things they needed it to do. Okay, there are a lot of horror stories in game development that go like this. Our content team was moving pretty fast, but then we had to stop. The engine wasn't ready. And they have to stop. They have to lose 3 or 4 months as the engine catches up, okay? A mismanaged in-house engine can kill your game's production, okay? So with this looks like a bloodbath, okay? Are you going to choose an in-house engine versus an off-the-shelf engine? I don't think so, okay? Unless what? What is the one dominating cataclysmic reason you might choose to make your own engine, okay?
you need features that one of these off-the-shelf engines don't have.
Bingo.
You absolutely need most performance, and you're optimizing for a specific genre.
Bingo. Okay? Bingo. The thing you might need, the thing you might pay anything for is total control, customizability, okay? If you pull Unity or Unreal Engine off the shelf, who's to say you're going to be able to be any different from all of the other teams that did the same? Halo used to be on their own in-house engine, okay? Infinity Engine, I think it was called. And that Infinity Engine was built to be able to do special things, a seamless, large, open world for their new title, Halo Infinite. But now, they have moved to Unreal Engine, okay? And if the next Halo that comes out feels maybe just a little too similar to a Call of Duty or a Battlefield or any of the other Unreal Engine shooters out there, you might know what to blame, okay? Anyway, right? The secret sauce is often in the engine. Off-the-shelf engines are sometimes customizable, but sometimes not. Large studios can actually get a license to Unity's source code, can pull it down, can make edits to it, recompile the engine if they want. Unreal Engine has source that's available. You can make customizations if you want. But if you absolutely require full customizability, if you want to make a special engine that is faster than normal engines can be, then you just have to go in-house. That's your only choice. I'll give you a very concrete example here. Sometimes it's Paramount. Sucker Punch has their own engine, and they are not a large team. They are based in Bellevue. They're one of the smaller Sony teams, and they tend to move slower in their production than other Sony teams. Not a bad thing. It's actually very impressive what they're able to make. Okay, Naughty Dog puts out a game seemingly every 2 to 3 years. Sucker Punch on Ghost of Tsushima took, I think, about 5 to 6 years for that game. Okay? Now, Sucker Punch has their own engine, and they are renowned for having some of the best particles in the entire industry. Smoke, fog, right? Leaves in the breeze. This gorgeous footage is running at a strong frame rate consistently on a PS4. If you know anything about consoles, you know that these consoles are weak, okay? They are potatoes compared to even your most basic gaming PC desktop setups, okay? I'm going to prove it to you, okay? Some of you have seen this haunting image before. You know what this is? This is my low-poly classic PS1 style survival horror game. Should be easy to render, running on a Switch. And if you zoom in real close and look, it's running at 13 frames per second. Okay? You do not realize how crappy, how cheap these pieces of hardware are until you try and run your code on it. Okay? This is in Unity. Unity games have historically run pretty poorly on the Switch and even on stronger consoles, PS4, Xbox. That's how it is. Now, you get this gorgeous result here because you have a team that is dedicated to building an engine precisely for one specific piece of hardware and for one kind of game, genre, okay? Open world game, we need the best particles in the industry. We're going to pay anything to get it, okay? And they got it. And people play Ghost of Tsushima because you're not going to find better particles or probably a better representation of the Japan of the era than you get from that game. That's really important to Sony, okay? People will buy a console just to play a game like this. You cannot get this on PC. You cannot get this on Xbox or on Switch. You want to play this game, you have to buy Sony.
I just wanted to add also that one of the main features of the game is that the wind direction tells you where your quests are.
Yeah.
So having good particle effects is super cool.
Yes, right? So the team that's known for particle effects wants to find a good use case for particle effects, not just as a graphical showcase, but for gameplay as well, and they did. So again, in this game, they don't have a weird compass UI like, point me to the next objective. No, lame. What they do is you can summon the power of the wind. I think in-game it's the wind goddess or something. And you follow the wind, and it will take you to your objective, okay? Really cool. Very immersive. Yes.
Just added a PC port.
Oh, did they?
Yeah,
Heck yeah.
recently. I don't know when, but it was within the past few months.
Very good. Good. I bet it runs. I bet it has pretty minimal performance requirements. But I've definitely seen console games that get kind of ported to PC in a sloppy fashion. It's like the game was designed and made and architected for a specific piece of hardware. When you just throw it onto PC willy-nilly, it's like the performance is surprisingly bad and a bunch of stuff is broken. Anyway, right? But if you think about Sucker Punch, right? Their mission is not to sell copies. Their mission is to sell PlayStation consoles. Okay, they're the kind of companies that say we're going to put in the massive effort and we're going to deal with the costs of having our own engine because that's going to be our secret sauce. We got to have secret sauce so that people will buy Sony PlayStations. Okay, we don't have secret sauce. People stop buying the console. Why would you? Just wait for the Steam release. Okay, no big deal. All right. Anyway, control actually is sometimes paramount. Okay, I'll give you another quick example. Let's talk about Stardock. Stardock is a fun example. They're one of my favorite companies. They are in the, they're in the state. They're 20 minutes away in Plymouth. They're our biggest game studio. They just had a big hit, Sins of Solar Empire 2. So they've been hiring a bunch of my students. They hired a couple of my game engine architecture students from last year. Anyway, Stardock is a multi-engine studio, and they're famous for really large simulation games. Okay, they are a rival to Firaxis. They make rival games to Civilization, Sid Meier's Civilization. So they make games like Siege of Centauri, Gal Civ, okay? When you look at these kind of games that they make, they have just like millions of units all being simulated at once, okay? And so for this, right, they have a particular engine they use. But they also make games like Political Machine, okay, which are slower paced games. They don't have as much going on. This is the kind of game where it's like, do you need a custom game engine to make this? Not really. So they use a different engine, okay? Over here, they use an engine. It's not called the Stardock engine. It's called the Nitrous engine, okay? But over here, for these kind of more tame kinds of projects, less risky projects, they use Unity. So if you were to go work at Stardock, you might use their proprietary engine for a few months to work on one game, but then you get switched over and you use Unity to build another. Okay. In fact, one of my former students was made the latest Political Machine game. I think the 2024 edition. He was like the lead dev on that. I think he might have been like one of the only devs, one of the only engineers. So very proud of him. He didn't take this course. He took 440. I think that was the only course he took of mine, but he did a great job. Anyway, so you do have engines, right? You have companies that say, hey, I've got different problems, so I'm going to use different engines for those problems, engines that make sense for them. So this is all to say sometimes you'll use off-the-shelf engines. Sometimes you call for, hey, we got to have something very custom, very fast in this case, exceptionally performant to handle all of these units simulating at once, and they were able to do it. Really impressive stuff, okay? Oh, also another thing, Stardock gets deals. I can't tell you about some of them, but Stardock is a famous company because they are known throughout the industry for having these kinds of engines that can handle gigantic, massive simulation games. There are companies, it's not public, there are companies you've definitely heard of talking with them all the time because Stardock is like one of only a handful of companies that can make the game that the publisher wants to make. So that secret sauce can also help you get jobs and get contracts and deals as well. Anyway, let's talk about some universal engine traits real quick. All game engines, and if you've taken 494, 440, you already know this, right? But not all of us have. That's just fine. All engines promote iteration. Iteration is exceptionally important because when you are making an entire new world a reality, when you are playing God, it's hard to get it just right on the first try. Okay? And so when you go into most engines, the engine will really focus on being fast and getting you into the game as fast as possible. Okay? You will often see at the top of these integrated engines, you'll see these little play buttons. You click on the play button, Boom, just a moment later, you're already playing the game. You can pause the game so you can study the world and figure out what you like, what you don't like, and then you can end it, make some changes, restart, usually in seconds. A super tight iteration loop means that you can experiment and get things just right. A quick story on, I had a lot of students on Halo Infinite, and that game was kind of doomed. People liked the game, but they also felt that many aspects of it were a little bit generic. There were moments in that development process where for like an entire month straight, the engine would not build. The game wouldn't build. It was broken. The build was broken. If the build is broken, you can't play the game. If you can't play the game, you can't test the things you're trying to put into the game, so you don't know if they're any good or if you'll have to throw them out or change them. And so you get into this awful limbo where you're trying to plan things out and build stuff, but you can't do any testing, and so you know it's all going to fall apart. What do you do if you can't test? If you cannot experiment, you can still do okay by doing what? And this isn't so fun. By going generic, by pulling a genre off the shelf, by pulling mission designs that you've seen in other games off the shelf, you know it's going to work, it worked elsewhere, but what really gets wrecked is your novelty, okay, and your polish. And so that's kind of what happened on Halo Infinite. You just could not test things for long periods of that game. The DevOps process was a mess, apparently. Anyway, engines will make it quick and easy for you to go around this iterative design process, make changes, test them, all that good stuff. The Sims 4, okay, most engines will also provide you with scripting functionality. Most engines are either written in C or C++ for performance reasons. But C and C++ are very fast when they're running. They're not fast for developers developing, okay? These are very difficult languages, lots of foot guns, and they're slow to develop in. So The Sims 4, for instance, we got to the point where our C++ compilation process took about 45 minutes to complete. Wow, that's awful, okay? The good news, though, is that C++, only a few teams cared about that. My team did not. We did all of our programming in Python, okay? The Python layer sat on top of C++, and Python is an interpreted language. It doesn't need to compile, okay? You just change the Python script, you launch the same C++ build, and you've got a different game really fast. It was great, okay? But other languages like Lua, C#, right, Python, all of these scripting languages offer more features. They offer more forgiving runtime environments, okay? You're not going to crash if you have it off by one error necessarily. You might. And they're often sandboxed. So if you do have an error, the entire game doesn't explode. You just move on to the next frame and the other scripts can run, okay? Anyway, scripting, right? Really quickly, scripting can be textual. For instance, this C# programming language, but it can also be visual, okay? There are quite a few visual programming languages out there these days. Blueprints, if you want to get really good at these, you take EECS 440. But you might have felt them in your beginner engines, your drag and drop engines, your MIT Scratch, your Game Maker. They have kind of node-based scripting languages. The thing to know is that they're the same, okay? In general, anything you can do in a textual programming language, you can also do in a visual node-based language. The node-based language is slower to write, and it's more visually spaghetti, okay? But it's a bit easier for newcomers. Okay, if you're not a programmer by trade, you cannot accidentally miss a semicolon here. Okay? You can't mistype something or have a typo. Okay, it's just not possible with nodes. There are only certain nodes. You search for the node's name, you find it, boom, it's there. Okay, over here you can move much faster. In particular, mathematical expressions are much easier to write in a textual programming language. But, you might have typos. Okay? You might get caught up by a bunch of those really early programming mistakes. I remember losing an hour, okay, to an extra semicolon. It's the classic, starter bug when you're getting into programming, into computer science, okay? All right, let's keep going. Often, these components and scripts are reused across many different objects, okay? I'm not going to dwell on that fact. We'll talk more about it later. A quick thing to finish up about engines, okay? No industry is safe. Engines are now of use to many different companies, from marketing and advertising to defense corporations, okay, to research groups. One of the reasons I made this class is because a lot of our research groups on campus really want students, right, who are able to do things, visualizations, without necessarily using an off-the-shelf engine. Another reason I'm developing the 3D art course is because laboratories want students who can make 3D models and characters and environments. And so, right, no industry is safe from these game engines. They're taking over everything. Unity and Unreal are big engines. They need to keep growing, okay, to keep their stakeholders happy. They don't have to keep growing, but they have to try. And so, Unity and Unreal have saturated games, and so they're moving on to film and video, as we saw last time. They're doing stuff in architecture, automobile stuff. Unreal Engine has an office in downtown Detroit. It's not a big office, but it exists primarily to try and get auto companies and their suppliers onto Unreal, using it for different things, okay? So the summary here, this has been a lot of stuff about game engines. Do you need to know all this? Not really, okay? But keep some of these things in mind as you develop your own engine. That question about, do I choose an in-house engine or do I grab one off the shelf? It's a really interesting debate these days, okay? It looks like off the shelf is winning. Unreal and Unity are everywhere. But you know what else is happening? Unity and Unreal are everywhere. But there are also a lot of complaints these days that games feel a little bit similar to each other, don't they? And I can't help but wonder if maybe we're in for a reckoning, and maybe we might have an in-house, from-scratch engine renaissance in the next half decade or so. We'll have to see, okay? AAA game dev is in a bit of a mess right now. We'll have to see what happens. So here are the takeaways for the day, right? The common engine model, right, is that of theater. Okay, a lot of concepts and terminology is from the world of theater, and there are a lot of connections and similarities just in a basic level. Okay, so keep that in mind. There are 3 types of engines out there. We've got the beginner drag and drop, we got minimalist engines, we got integrated and industrial grade engines. They all have their place and they've all got their fans. Okay. Off the shelf versus in-house is a really interesting question. Off the shelf is winning big time these days, but we could be in for a renaissance in-house, right? If you have to have a secret sauce to stand out, then in-house might be the play. Despite how difficult it is, despite how expensive it is, you might have to do it, okay? There are universal engine traits across all engines. They all want to get you quickly iterating. They all want to give you access to editing of assets and logic and scripting. They want to make that fast and easy and quick. And these engines really are taking over just about everything, okay? If you expect the future to become a highly visual and interactive one, if you watch films that feel futuristic and you see holographic displays everywhere and people wearing glasses that bring augmented reality objects and things to life, wasn't there recently a tool that allows you to like see someone's name or something by looking at them through the glasses? It was really controversial. Do you know what I'm talking about? Yeah.
About the Shinigami eyes from Death Note?
I don't know. Maybe? But there was some tool where you had glasses on. They were like the Meta Ray-Bans or something, and it would recognize who was you were looking at. It would look them up via their like Facebook information. That's a bit creepy. And it would tell you their name and last name, so you could just walk up to them without having met them before and say, hello, Ethan, right? And it was very creepy. People didn't like it. But if that's the future we're heading to, we're going to need some game engines, okay? And they're going to have a lot of work to do, okay? So anyway, we will, within the next week, move from talking about game engines as a concept to building one ourselves. At that point, we're going to move very heavily into C++ concepts and things that will help you build the engine more efficiently, more effectively, and in a more maintainable, scalable way, okay? And so I hope you will look forward to all that business starting next week on Wednesday, we're going to do that quiz, okay? And we're going to maybe start getting rolling with C++ concepts, okay? So everyone, office hour starts now. I'll be here for the next 2 hours. If you're bored, we got HoloLens available here. The 440 students get dibs, but if you want to experience HoloLens, we got them back here. And I'll see you next time, okay? Take care, everyone. Bye-bye. Oh, by the way, if you have any waitlist issues, if you're not in the course yet, send me an email right away. I'm going to send you in and request an override for you tomorrow, okay? So look forward to that. Okay, online, everyone on Twitch and YouTube, I'll see you later. Take care. Bye-bye.